Hi, I'm 126. Today I'm going to teach you how to use Civil 3D to analyze Earthwork volume. In this video, we will learn how to calculate the cut and fill volume, how to draw the red and blue area, and also how to create a 3D model. Step 1. Setting for matrix. First of all, you have to confirm and make sure all your settings are correct before you proceed to the next step. Now, I'm going to teach you how to convert all the unit in matrix. First, you have to check the drawing utilities and go to drawing setting. And first, you have to check whether this is in area, in meters, and then you go to ambient setting. Make sure all these are in meters. Volume are also in meter. And click OK. Second, go to option, and then you have to check the template all are in meter also. These two you have to confirm it's in the meter. If it's not meter, you can click browse it and then you change to matrix. And then the second one is this one. If it's not in matrix, you have to change it to matrix. Set civil matrix, browse set civil matrix, click open. Okay. In order to calculate the cut and fill volume, we need to compare two surfaces. One is a proposed surface and another one is original ground level surface. There are three methods to create the surface. So I'm going to teach you one by one how to creating the surface. Method 1. Define surface from text. This is the survey plan usually we get from the surveyor. So now I'm going to show you how I convert the text to the surface. As you can see, there are two types of the text. We have now one is this one, this color and this color. So we can select both of that. After that, we right click and select similar. We check and see whether anything left. If yes, then we select that text again, right click it and select similar. Okay, we have to make sure all the text from the surveyor, that means just the levels, have to select first, and all the text, yes. Okay, and this text also select similar. Okay, after that you just right click, isolate it. Okay, this is the point where we get from the surveyor. Now we have to convert it into the surface which we want. First of all, we have to make sure all the text it have the z value. If you cannot see z value, you can usually, what I do, I like to use the quick properties. From these things, you can click from here, you can search for your quick properties, and this one you tick. After that, you show the quick properties. In your tab you might don't show, so here how I click it to show it. Usually I click this one. From the text, I want to show the exact position for that things, then I click OK. So it is very convenient for me to show the exact position. And I see when I check this, the exact position is not in the correct value. So the first step, we have to convert and move the text to the correct exact position. You can select all these things. After that, you just type move text to elevation, which is this one. You just click on that, and then you will find that just now which is not correct one. Now it all become correct already. 59.3. You have to go to another point and check and see. 62.27. Okay, now this all the level are correct and have go to the level which you want already. But I'm not sure whether this IL they can define or not. Of course, because AutoCAD they cannot read the IL. So we have to convert this IL. We will make it become value instead of there is a alphabet inside. How to do that? You can use find. Okay, this is the steps. You can type IL invert level and then you replace with 30. We want to put 30 means when we saw that value, when we see the value, we know that this is the invert level. You just click replace all. You see, as you can see, all invert level are changed to 000. Okay, and then we click done, and then we have to redo the things again and make sure all this value have moved to the value which we want. Wait, hold on. There's another value which is not correct yet. I mislook up. There is another ILS. So we have to change the S thing to 0 also. We cannot left the things. Okay. Now we click find. We click S and change it to 0. 10 should be sufficient. Replace, or if we don't want to replace it with 0, you can just remove that. But I want to put 10 to make me convenience and replace all. Make it 40. That's all. Done. After that, we move text to elevation again. And now we check again and see. I'm sorry. Move text to elevation. Select all the text. Enter. And check again. Yes. Now it's on the correct value already. The next step, we have to change these things to Civil 3D. For drafting, you can use draft and annotation. But for Civil 3D, to create a surface, we have to use a Civil 3D mode. Okay. As you can see, here are the items that we usually do. You can create the points, we can create the groups, but most importantly, we have to create two surfaces. Now we will show you how to use the surface. So you can click on that, you drag click, you create new surface. Okay. Now usually I like to create a new layer for that. Means I can create the new layer. I like to put it C3D, Civil 3D, OGL. This is my style. You can create your own style also, and you can create anything which you want. You can create a new one. Okay, so I created that one for my layer. Then I click OK, and then the surface I write original ground level. Okay, after you create the surface, you click down this here. You can see this is the OGL surface. So we have to define what is OGL. We have to make the levels all this point and make it become the surface to define it. So we click the definition, and then we go to drawing object, we right click and add, and we don't want to point, we just choose text. Okay, after that we click OK. We select all the text and then we click enter. Okay, one thing I forgot just now, when I create the layer, I close the layer, so I open it again. Yes, here is my layer. This is my surface, my first surface. Its surface actually what is shown like just a line, because I haven't setting it for this surface yet. Actually you can setting it for this. You can show it properties, and then you can see you can see no, you can right click edit surface style. You want it to show display something like border, contour, elevation, slopes, elevation. Let's say I apply and see, you see this is surface. The deeper blue means it's very high, and this one is very shallow, and this one is high. Okay, and actually you can change all this, change the color. You can right click surface properties, and then you go to analysis, and then you just choose elevation also. You can actually make it into a few colors. Here they make it become eight different, if I want the two color, and I can click it. The level from this level to this level is this color, this level to this level is this color. Actually it's okay, it's up to you. You want the two color, three color, and whatever color you want is okay. This is just show how the things. You also can have see to check whether is that your point got any problem like errors or that like that. You can by clicking your thing, selecting it, thin surface, you see, right click, you can view object, and you can see the 3D modeling. You see, if from here I can find that actually there is two things not really correct which I want. So first of all, I believe it's this point and this point. I believe there is something wrong and make this surface like suddenly got come up like this. I believe there is 2 point which is not correct. We can check on that. Okay, we can click the surface, and actually if I don't want to see the surface, I can bring it to back. So I right click, display order, I send it to back. So from there just now we know that these 2 point actually does that make sense? We have to check it back. Again, we can right click, isolate, and then you end object isolation. We can see we can from there we can see, we check again whether the 2 point are correct. Is really 77.47 or not? If really yes, you can let it. But if you think this point is not correct, you have to delete it. If you found it, because for the surrounding there suddenly got 2 point come up, I believe there is some mistake for the surveyor. You can just delete it. Okay, but it's okay, this is just demo only. I just show you how to create the surface. Now this is method 1, how to create the first surface. Method 2, define surface from point. Okay, continue from method 3, define surface from contour line. Okay, method 3, how to create a surface from the contour line, and which is this one. First, you have to make sure all these contour lines are in 3D polyline, which means it really is in the 3D one. You can select similar. After that, you can click on and see how is it. Is that really a 3D? Yeah, it's like that. Okay. I believe all these things will give you a 3D, and this point, if it is not really like continuous one, it might have a little bit difference. So usually for myself, I don't prefer to use this method, but I will show you how to convert it also. Okay, so you can select all the points. Now you select similar. After that, same, right click, isolate the object. Okay, and these are the contour lines, and you have to see which is not 3D line, and you have to remove it. Okay, you have to make sure all others are just 3D polylines, which means it really have the levels. Okay, if you want to check whether these lines are in the correct value or not, actually you can do it this way. For each contour line, it have a specific value for that things, which means if I put a point, I use a point, point, I create a point on the things. I have to click snap it on the things, and then and you click on the point, you will find that it's on 60, which means this contour are in 60 and this one is correct. And I will show you another things, another point, and see this one lower down one is 59. Any point create on the contour line is 59. It's the same level. Okay, now this, after we confirm all these points are correct, the next step we have to convert it into a surface. The same method also we do. We create a new surface and then we choose the layer which we want. After that, we rename it as OGL, original ground levels. This one is contour to surface. Done. Okay, after that, we same method, we define it, we use contour, click add, and then just click OK wherever. This one, the distance, we have to look at it, click OK, select that and click enter, and now you have the new surface for that things. Object viewer, it might have slightly different because it is generated by the surveyor. So now we can compare three of that just for your checking only, in case there is any difference. As you can see, this is three surface we create. This first surface, we click on this, is like this, and another surface is like this. This is roughly the same except this point and these 2 points, because I believe there is these 2 points are not really in the correct value, is quite far, and actually we can delete the 2 points if you want. Actually you can like do it in this way, but I will show you in later on. This is how we create the surface from the contour. Step 2, create proposed surface. Okay, now after creating the OGL surface, we have to proceed the next step, which is create the proposed platform. In order to propose platform, now we have to close the surface which we create first. Okay, so we have to draw one platform on this one, and you can directly copy your proposed platform into it, and this is what I prepared before I do this. Okay, as you can see, I want to create a platform in this red boundary, and I want to make this one in one platform, this one platform, this one platform. So I just want to show whatever I want to see, while the others I will close the layers. Okay, I just left this one. As you can see, the mainly AutoCAD, the best way to create a platform, I prefer to use contour. So which means you have to choose polyline for the platform which is flat, and also the platform which are flat. For those which are not in flat, I prefer to use 3D polyline. So how to create this 3D polyline? Says this is the road, this is various levels from 63 going up until here 63.322 and 63.80, and also at finally at 65. So I close the polyline first, I hide it. Okay, so I have to initially, so I have to create the point first, create the point at the edge of the roads, where from where to where. Okay, says I make an example, I click point, okay, point first, I create one point, and then I make a level, let's say 63, and then the second point I want to make it at this level. I will make it another level is says 65. 65. So I create a line to connect that. So for the middle one, actually you can interpolate that, or you don't have to do that also, never mind. Or you, if you have another levels, you can use the point, create another. Let's say this one is 67. So you click lines to do that. So I just to use preferred lines instead of you use polyline for this, because it have two different z value for that, 65, 63, and this line 65, 67. Okay, so in order to convert this line to become 3D polyline, you have to click these two lines and click join now, and this line will become 3D polyline. So for this road, you need to create two contour which is 3D, but in 3D if you have different level, which is from 63 up 63.38. This is what I want the road looks like, 65. And this one in between that, you can use polyline to connect these 2 points, but if you don't want also, never mind. This is an example. Okay, so we go back to here. First, after you draw all the polylines, you have to make sure there is some space between these two different platforms. This is because AutoCAD will automatically generates one slope for these two levels. Says this 65, this is 63.5. This is a different level. AutoCAD will automatically generate the slope for that. They will directly match the slopes. Okay, so now for the same method, we have to create surface. The surface, I choose one platform level for that. I click OK. Next one, I click propose from the name, and then I choose contour for this. All these lines are selected. Okay, so we go to the next, which is enter, and we can see our proposed platform. Oh, because I closed the layer, I haven't turned on yet. I turn on the layer. Okay, sorry, this is OGL, this is PGL. Isolate, no, isolation. Data. PL. What's going on? I haven't defined yet, is it? PW. Where is my undo? Again, add. Okay, select all, enter. Yeah, this is my levels. So I can get this. If you can see view object, this is platform which I want, but okay, and this is the road. You see, very smooth up to there, and but this part which is what I don't want, this is extra part. So how should I do for that? Actually, we have the boundary for that things. Okay, we can send this to back first. Okay, you see, I just want in red color only, the boundary for the red color only. For the beyond boundary one, I don't want. So I can add a definition to the boundary, which I can add. I click this one. Yes, you see, I select the line first, then I click add the boundaries. It automatically come up like this. This is what the surface of the proposed looks like. See, very nice, very clean and clear. Sometimes you have to do this level many times and practice, you only can get a perfect surface. Okay, that's all for the proposed surface. Step 3. Creating a control. Sometimes we don't know the volume we calculate are correct or not. Like when we do an experiment, we need a control to make sure we have something to compare and the control are correct value. How to do that? Let's see. In order to create a control, it's very easy. We just have to create two platform also. Later on we can compare. The first platform, you can just draw a rectangular, which is very a big one, and then with a center, small one, at the center, but with a specific dimension. We give it tens times tens times tens. Okay, and this platform we make the elevation become 0, and this one we make it elevation become 10, which mean later on we what we get, we will get something like tens times 10 times tens. The volume should be have 1000 m cube. Okay, if the volume you do cannot get this value, which mean the unit are wrong or something else is wrong, because the area should be, the volume should be in 1000 m cube. Okay, now we have to create two surface for that also. So we create two surface, we name it as the layer wherever. It's not important, it's just for test. I just see it for test. Okay, we choose the test layer and surface test OGL. Test OGL. Okay, another surface I create for same layer. This is test propose. For the test OGL, we define it using contour. Add. Okay, we select the OGL, and then we compare to another propose. We define that one as PGL. Okay, now you have the two surface for the test. Okay, wait, hold on, where is the surface? Yeah, the thin surface is here, but it didn't show up. Actually it already created, but it didn't show up. It is because I didn't set the surface properties for that. Actually you can do edit, you can show, but I don't want to show also can, because it didn't display the elevation. This elevation, but it is in flat, so nothing to show up. Okay, it doesn't matter as long as there is thin surface for that. 4. We have to cross check whether the survey points are correct or not. As we can see in previous just now, we found that there is a few points which are not logic, so we have to correct it. After creating the control everything, now we have to go to check whether the surface are correct or not. As we can see, there is 2 points here and 2 points at this point are not correct. So you can either choose to correct the value or just delete the point only. So for myself, I prefer to delete the point, because this point will cause the meshing differently. So this will give like very an inaccurate result. So actually it is very easy. Since all those are linked, I can just delete the points only, and then this 2 point and this point, this which gives 77.4, and this point 50 something, this point 50 something suddenly go to up to 70, mean these two 70 points are not correct. So I just delete the 2 point, delete and delete. Because of these 2 points are interrelated with the surface, after I delete the things, the OGL point it come up an error, which means it's different already. It's no worry, you just have to click rebuild, and then you click rebuild. Okay, now it will generate a new one. Now you can see again, is there any error come up? See, the platform become almost flat already. This is what we want. Step 5, analysis. Now we came to a climax where the step which we want. We can click on the analysis here, and then we click volume dashboard, come out like this. So we have to create another surface for the different. So same also, we create one layer for that. We name it as 00 C3D volume. This is surface for the volume. Okay, click that one, click OK. The name, so we have to run 2 times. The first one we say test volume. So we have to choose the base surface for using OGL, test OGL, and the compare surface propose. So what we should get should be something like, okay, if we show out of that, we have to check, because there is something error at there. So I believe the thin, hold on, there's something wrong with these 2 layers. We have to check again and see. Thin surface, test propose, this is volume. Yeah, it's correct. Okay, so we have to rebuild for that, for which have error one, we just rebuild only, that's all, rebuild. So as we can see now, the volume we get, yeah, exactly 1000. If you get not, the result is not 1000, that means you have some error happen in the unit, and you have to make sure all these are in cubic meter, which you really want, and this is a control which we mean just now. After that means control correct already, wherever you calculate the volume is correct already. So for the second one, I proceed to my proposed one. I click volume also for the layer, and then this one I put cut and fill volume, and then base surface I choose OGL, which is point just now we do one. Click OK. Surface I choose the proposed one. So compare. Yeah, here is the cut and fill volume which we want. As you can see, there is net fill. We need to fill this amount. Okay, you can give you want to run a report on that. This is your report, cut and fill volume for that. How much is the cut, how much is the fill, and how much is the net. Seems like we need more of around 145 m3 to fill the area. Step 6, the last step. we have to color the red blue area, which where red color means cut, blue area means fill. After we get the volume, now we proceed to our next step, which we have to make the where is the cut and fill area to show in the plan. So you have to select the thin surface, okay, you just isolate it, okay, for easy selection, okay, and then cut and fill volume, just click repeat. Okay, no problem. And then you have to edit the things which involve just now, the surface for proposed volume. Hold on, cut and fill volume, yes, this is the surface. After that, you have to surface properties, you click on the analysis, and then for the elevations, and then you click two, because we were just want two color only, which means it's red and blue. For those below 0, actually we set this one become 0, this one okay become 0. For all levels which is below 0, it means cut. Wherever above, it means fill. So we change it to red color, and this one we choose blue color. Okay, says like 160 or 150 if you want 151. Okay, these two color, then click apply, click OK. As you can see, for the fill part is just this one, and the cut part is this one. Cut part and fill part. And then you can just open back all the layers you want, click, and then you can send this thin surface to the back. Okay, yes, that is how the surface look like. That's all the lesson for today. Thank you. Thank you for watching. If you think this video can help many people, please give me a like and share this video to whoever you think he needs this video. Thank you very much. See you again later.